Hi, my name is Bianca, and in my data analysis project, I looked at the interaction between the N. fulva ants and the venomous S. invicta ants. When these two ants come into contact with each other in nature, the N. fulva ants are miraculously able to detoxify the venom from the S. invicta ants, sparing their life. In my report, I was able to find a correlation between the N. fulva ant survivorship and its ability to perform its detoxification behaviors. I was also able to show statistical significance with an ANOVA test. So this is the main graph that I came up with, and it shows the average percent survivorship of different treatment groups of N. fulva ants. These treatment groups consist of the control, group 1 and group 2, shown on the x-axis, and then the percent survivorship is shown on the y-axis. The control group is the group of ants that is exposed to S. invicta, and they're able to detoxify, similar to what you would see in nature. And as you can see, the percent survivorship for this group is very high. It hovers around like 92% or so, because they are able to detoxify the venom. Next, we have group 1, and they are not exposed to S. invicta and not able to detoxify either because their glands are closed. And as you can see, this group also has a very high percent survivorship because of the fact they're not even exposed to the venomous ants at all. Lastly, we have group 2, and this is the group that is exposed to S. invicta, but they are not able to detoxify. And as you can see, the percent survivorship for this group greatly declines because they're not able to detoxify the venom from the S. invicta ants. And this shows that the survival of the ants relies heavily upon its ability to detoxify. This research can have many implications, not just for ants, but also for humans. By examining how N. fulva ants are able to detoxify S. invicta venom, we can try to develop similar detoxification compounds for treating venomous ant bites or venom from other deadly insects. Since it is known to be essential to the survival of N. fulva ants, humans can observe and adopt similar compounds for use against other animal venoms. So here we can see the data repositories that I used with paper 1 on the left and then paper 2 on the right. The citations for the two papers are shown at the bottom of the slide. So for paper 1, I took data from the first tab that was labeled Staged Interaction Detox Test, and I only took the data columns that corresponded to the type of treatment, which is right here, treatment renamed, and the survivorship of the ants, which was time till death. And obviously, if it said NA for not applicable for time till death, I assumed that the ants had survived. And then from paper 2, I took the data from the tab labeled Detoxification Capacity Acidophore Sealed. You can see that at the bottom right here. And I took the data from the treatment and ablation columns for the treatment group. So those are right here, so I could determine which treatment group they belong to, as well as the 7-hour post status, alive versus incapacitated or dead column. So that is actually right here, and that would just tell me whether the ants had survived or not. Okay, so this is the data assimilation and calculations. So the table that you see above, the blue one, it compiles the data from both paper 1 and paper 2, and it takes the percent survivorship from both papers. You can see that in the columns right here. And then I took the average percent survivorship across both papers, and that you can see in the column right here. And lastly, I followed that with this standard deviation calculation to produce the error bars for the graph that you saw in the previous slides. And then I ran an ANOVA test. You can see the results of it right here. It's a single factor ANOVA test. And the main thing that I looked at is the p-value that you can see circled in red. And in this case, the p-value was 0.02, which because it was less than 0.05, I determined that there's statistical significance.